Hi everyone, I'm Abhay H. Kashyap from RV College of Engineering, and I'll be presenting my poster and project based on the comparative study of big data platforms for the analysis of astronomical data. Thank you for watching. The major objective of this project is to identify tools and resources that big data platforms like HPCC and Hadoop provide and their use in the astronomical data pipeline building. As you can see in this plot, the amount of data being collected by various missions to space has grown exponentially, and there is a need for an automated pipeline to process this data. Astronomical data is usually collected from infrared, radio, high energy sources, and from newer techniques such as gravitational wave detectors. We have chosen to test out machine learning pipelines where research has increased recently. The dataset we chose was from the Sloan Digital Sky Survey conducted by the European Space Agency, and it looked at various objects in the sky and returned its images. This data was then used by a citizen scientist group called Galaxy Zoo, who classified them into three classes: smooth galaxy, dish-shaped galaxy, and stars. To compare the two models, we first explored libraries in Hadoop and HPCC that were useful for each task in the project. Then, preprocessing is performed where each image is grayscaled, cropped to retrieve the center part of the image, and then compressed to a 28 by 28 pixel image. The machine learning or neural network model was built and tuned for this input. For building the model, we used available PySpark machine learning package, which has an API multi-layer perceptron classifier, and in HPCC the GNN bundle was used. Both models were then evaluated with the testing set and gave around 87% accuracy for 100,000 images. Here is a code I wrote in ECL for building the GNN model, and the code we wrote in PySpark for the neural network model in Hadoop. This is an example of a smooth galaxy correctly identified as smooth and one which is incorrectly identified as a star. To compare the two platforms, the following 5 metrics were used: throughput, scalability, capability in processing astronomical data, ease of setup, and ease of programming. Let's see how the two platforms fared. Hadoop, the throughput. It is calculated as the training time for the neural network model. Hadoop performed better with less number of training samples, around less than 10,000 samples, and gave an average time for 100 samples as 1.35 seconds. HPCC performed better when the number of samples was increased to 50,000 and gave an average training time for 100 samples of about 3.7 seconds. Scalability wise, both HPCC and Hadoop increase in performance when now more number of nodes are added to the network, but this increase is more drastic in HPCC, and that is the reason scalability wise HPCC is better. Capability in pre-processing astronomical data. This is calculated as the pre-processing or the image processing time. For image processing, 0.5 seconds was taken per image by Hadoop, and operations such as grayscaling, cropping, and compressions were performed. HPCC is currently developing image processing tools, and thus no metric is available. Ease of setup. System level configuration is required when setting up Hadoop and Spark, but that is not in the case of HPCC, and installation is much easier. Ease of setup time. The estimated time for setting up Hadoop is around 2.5 hours, and for every half an hour for an extra slave node. Estimated time for HPCC setup is about 1 hour and around 15 minutes for each new node. Ease of programming. Multiple languages are available in the Hadoop environment such as Python and Java, but for HPCC, ECL is the data-centric language that is used and is easy to pick up. The results show that when dealing with large data and hoping to build a fully automated pipeline for the analysis of astronomical data, HPCC provides a better platform which is easily scalable. Some disadvantages of HPCC where it can be improved is increase in the number and type of machine learning algorithms supported and its documentation, as well as including other types of data processing in HPCC such as image and digital signal processing. I would like to acknowledge the support of RV College, my mentor Dr. Shobha G, and HPCC Systems in the execution of this project. Thank you.